Hello, everyone, and welcome to edition 83 of the Core Developer Meetings. Um, Getting started here. This one is not going to be as long as the last 3 hour meeting. This one's going to be the hour and a half that it usually is. And so, first, let's go ahead and talk about it looks like EFI review. So, is that something we should wait until after we get to some of the other EIPs, James, or?
I'd say let's see if I can do the Berlin ones quickly, and then we can go into the other ones. There's a lot of good proposals to talk about stuff we haven't talked about before, so I want to make sure there's a good amount of time for
I
those.
agree. Okay, yeah, go ahead with Berlin and EFI then.
I'll do the Berlin ones. So 1962, we superseded by the BLS signature working group one, which that is 2537. I don't know if Alex is here yet to talk about it, but they just finished the specification is like frozen at this point, and now they're working on finalizing testing and
Which
pressing us.
Alex? Because there's two in here and an
Oh,
Alexi.
is Alex Vlasov here for a quick update?
I think. Oh, are you on mic, Alex?
Yeah,
There you are.
yeah.
Yeah.
Well, I'm here. It just depends which form of update you want. In principle, spec is more or less final and frozen. It was kind of the last part which was missing was SCAF schedule and ABI update, as I promised last time. So in principle, right now it's only to provide implementations. It will not be changed anymore, or at least it should not be changed anymore.
Is there any update on the hash to curve, and if that's gonna fit in with the?
The pull request was updated with the information about hashing to curve. So as was discussed previously, hashing to curve usually involves two parts. One is hashing to the to the field element, which is done, which can be done in EVM, and this part has more than one choice. Like you can use different hash functions if you want. So this part we don't implement as precompile. We leave it as a functionality which is implementable in just standard smart contract with maybe like 20 lines of code. And then we do the operation which is mapping of the field element into the curve point, which is non-trivial and which is expensive. And this second part is specified as a precompile.
Great. Thank you for putting all that together.
Awesome. And just to be clear, this is the thing that is needed for phase 0 of ETH2, right?
I'm not direct. I mean, this is at least how I understand what is necessary to check BLS signatures, because you have to hash it to the curve point for this purpose. But I cannot give you 100% answer because I did not try to implement it and didn't check. But it's most likely that's it.
So to
I can
be
confirm.
clear, nothing on the ETH1 side is necessary for phase 0 of ETH2 itself. The thing that both BLS 123D1 and hash to curve are necessary for is having a light client of ETH2 inside of the ETH1 chain.
Okay, got it. So it's a nice to have, or rather.
And it's a very nice to have, I think. Like
Okay.
one thing that it'll enable is it'll enable rollups that use ETH2 as a data source before the two chains merge completely.
Okay. Thanks for the info, everyone. You can continue, James.
Great. The other one is EIP 2515, which is the difficulty bomb freeze. I haven't done very much work on that because there's a lot of other things going on right now. But I will get back into updating the EIP with the suggested changes from the community. EIP 2315, simple subroutines from the EVM. Do you have any quick updates, Greg, for that? My memory was Viper was going to look at some kind of like looking at what it actually would do in a production change.
I'm not sure what Viper's up to.
Actually, I pinged Bryant about it, and he said basically, yeah, it's got thumbs up, and they're looking at making use of it.
Yeah, I know
Uh,
they've always been supportive. I just don't know where they are as far as code. It looked like you were pretty close to code complete on that. Is that true?
Yeah, so I can give a little bit of an update. So this has been implemented as specified in the EAP. It has a PR for Go Ethereum. You can run it, you can produce test cases and traces from it. I do have a couple of, yeah, I think it should be changed a little bit. And I've been trying to raise some people to look at it and yeah, discuss it more in depth.
Good.
The changes that I propose are pretty small, doesn't change it significantly. And I tried to loop in also the Solidity team, and Christian Reitwiesner is like, it feels like he's a bit on the fence. He's a little bit positive, but it's not like he seems to be a big driver for him. I mean, it doesn't seem like this opens any particular new doors per se.
No, Solidity solved their problems long ago,
Yeah.
but getting it implemented is a step you need for people to look at it more carefully.
Yeah.
Great. So that sounds like it's getting some progress, and I'm looking forward to seeing where your suggestions come in, Martin.
Yeah, I mean, if it would be great if the people on this call who are deep into the EVM can take a look at the discussion and my proposed changes. I think it's basically it contains a hack right now, and I want to get rid of that. And then there's the discussion: should we allow walking into a subroutine instead of jumping to it?
Do you have where would that discussion be? Is that on the Ethereum Magicians
Yes, it is.
discussion? Okay, so it's on that. So people who are interested should go to that forum.
Exactly.
Please. And that sounds good to me. If there isn't anything else, the EIP 2456, which is the time-based upgrades, I've been following up a bit on this with Dano and others, and there is the reason why that we went with the time-based with the look back was because of weirdness that could happen at the time of the fork if uncles or Amers were involved at the block at the time or at the time rather than just the block height. And so that's why look back was look preferenced. And Jason Carver had some feedback that we would lose some things being able to inspect, like being able to know we're at the head of the chain by being able to look at the current head of the chain and know that is the valid one. We lose that if we have this kind of look back functionality, internal retrospective for that. So Jason has some suggestions about ways we could change uncle rate rules that would perhaps address that concern, and then if that is resolved, that perhaps we could just have a time-based fork that doesn't have a look back function. Just say it'll happen at this time, and then the block that happens.
Is the look back you're referring to just that we're going at the block after, or is it that we're doing this kind of double hop after, like the second block that is modulo 0 of 1000 after?
It's the double commit version,
Okay.
or like 1,000 blocks after this, then it becomes activated. So it's the first 1,000th block after a certain point in time would then be the activation point.
James, I have a question. I thought we discussed the fact that the formula for the time, like we're talking about the time bomb, right? Am I correct?
No, this is the forking based on time instead of forking based on block number.
Yeah, but that's basically the only reason why we have to fork on time versus fork on block is because the formula is wrong. I have a feedback loop. If we had a good formula, I mean, that's okay.
That's not the
Please.
only
No, because
reason.
the variance, there's some variance in the block times, right? And because we set upgrade date, like 2 months in advance, it kind of leaves a window based on the block time. So with this, instead of having, like a week plus or minus, a couple of days on each side leading to a week of a possible range for the upgrade, you can say the upgrade will happen at time X, and then if it kicks in 1,000 blocks after that, you basically have a 4-hour window instead of a plus or minus 4 days window.
Yeah, and even under ideal conditions for block times, we still have that like plus or minus 3 days, I believe, if I remember correctly.
Okay. Perfect.
So one small issue with this kind of n plus 1,000 approach is that, at least as far as I can tell, that would implicitly require putting the entire, including the entire last 1,000 blocks of history into the state, whereas currently we're only putting the last 256 blocks of history into the state because of the block hash opcode. So it does kind of change the requirements of what clients have to have access to a little bit.
Yeah, and it apparently it affected beam sync and other things that people were looking at too.
Right. So, I mean, if you reduce the limit to two from, or the delay from 1,000 to 256, then I think it should not change any invariance at all, because the block from 256 ago is already used by the block hash opcode.
Oh, well, that's good to know. We had discussed making it a shorter timeline, but it turned out we were having trying to find the right timeline. Wasn't the real discussion was happening was that Jason would rather have it be a 0 look back. But you said 256 is already stored in memory, so that would be
Yeah.
Okay.
Wait, what I did not understand is that it is true that this 1024 looks like a magic number, and there's no real explanation about why this number was picked. Like, what is the rationale? And I sort of suspected when I read the EIP, I thought that the reason why this 1024 block exists in the first place, isn't it because two blocks might have the same timestamp, and if they do, then it's not clear which one activates the fork, or is it not?
It's not legal for two blocks to have the same timestamp. They have to increment at least one.
Okay, but then what's the issue? Can you just, because I don't
So
understand, it wasn't really explained, I think, was it?
So if you don't have a look back,
Mhm.
the problem that you may run into at a certain time is that it may include an uncle which has a previous number, but it has a later timestamp.
Okay.
And that makes that can lead to hairy situations because we don't know what changes are going to be made. But let's say, for example, it's prog power something where we actually change something that would affect how we verify the uncle.
Right.
Oh
yeah. Okay.
A good thing.
I understand. Okay. Well, yeah, I mean, I think I'm kind of with Jason here, is that I would rather say that let's say, disallow uncle around that block time or something like that. So that,
I think it wasn't Jason's suggestion to not allow a block to reference an uncle which has a later timestamp than itself.
maybe, yes. I think it does actually seem to me that these 2024 thing is just a bit too tricky, I would say. I don't know. And it is a magic number. So usually the magic number is a sign of a bad design.
But I think someone ran the numbers and checked if it ever occurred that uncles were in fact on a later timestamp than the block they were included in. And someone on the call last time talked about it. I think they found that, yeah, there were a couple of instances where an uncle has a more recent timestamp. And I mean, if a miner is on the wrong clock, he will generate blocks in the future, and they may not be. Thus, because of that, they will be uncles instead of actual canon blocks. So it is a legit thing that can happen.
No, I understand it's a legit thing. I'm just saying that so from my sort of intuition is that whenever you introduce the magic number, that's normally a sign of a bad design. And in this case, you have to dig into why this number has been chosen. and it sort of leads you to, if there's a solution which doesn't have a magic numbers, usually it's a better one. And I think the solution which will not require going backwards, from my intuition, is probably going to be a better one.
And that's the
Yeah.
fixing the uncle rules.
I would say
I'm wondering
yes.
if it's really worth fixing for this feature.
Well, if you wonder that, then you also wonder why. So essentially, the problem of the forks, or block-based forks, it does get exacerbated with the difficulty bomb, but otherwise, yeah, I mean, it's 4 days period rather than 4 hours period. I mean, it only matters like twice a year or something. So that's why usually the importance of such proposal kind of wanes after the fork. So I would still not be, yeah. Anyway, that's kind of just my intuition.
Given the discussion happening at this point, I'm less sure that this would be ready in time for Berlin. It's kind of my thoughts at this point, but I want to continue making sure we have the discussion. And I was hoping Jason would be on today so he could discuss what he was thinking, and then we can resolve.
I'm here.
Oh, you're here. Cool. Have you been following on the conversation thus far?
Yeah, unfortunately, I came in the middle a little bit, but yeah, I caught the last few minutes.
So your proposal for not having the look back involves something with the fixing the uncle rules, and then Martin was saying that perhaps that's not totally needed for that feature. So what would kind of be, I don't want to misrepresent what you're saying, Martin, or it's not that is more.
Oh, no, actually, yeah. So maybe I misrepresented what Jason said, but what I tried to convey was that I maybe think that I don't know if this EAP at all is worth the complexity it's going to take. That's what I was meant. But please go ahead, Jason.
Sure. Yeah. So, my take on it is that the best way forward is to do just a timestamp based forking without any look back, and just say that we fixed uncle rules in the form of, or further specify them in the form of either saying that uncles can't be ahead of the including block, or we could pick something and say, okay, they can be up to 2 minutes ahead of the including block or something like that. But I think it's fine to say they can't be ahead at all. It did happen a few times, at least in the first million blocks, but it's pretty rare. And I'm going to be running some numbers on the rest of the mainnet blocks soon to just have more data on it. But yeah, it just takes a few kind of cleanup rules, I think, to resolve it, and I don't think it takes too much. But yeah, I agree that the complication of doing lookbacks to figure out, for me, it seems most important to be able to look at a single header and know which VM rules apply to that header.
Yeah, can you speak more about that piece, because I wasn't able to communicate that very well.
Right. So to me, the idea of like, okay, so if you have either block-based forking or direct timestamp-based forking, you can look at any given header and know right away which fork that header is on. Right. So, is it a header behind this block number? Is it a header behind this timestamp? Okay, now I know which rules apply to it. Does it, what are the block rewards for this block? What are the other characteristics that need to be verified about this header? Versus, okay, well, now I've got this header. Now I need to go back and look at some of the other recent headers to even know what rules make this header valid. That seems kind of like it's not worth the complexity, at least not for this particular win of doing of knowing what window of being able to do timestamp based.
I'm going to time box the sub discussion. We'll finish up this sub discussion and then move on to the next one since we have a good number of things to get to and we probably won't get through all of them anyway.
Yep. Thank you, Hudson. You were right on that. And that is the currently Berlin thinking EIPs.
But like the conversation that Jason and Martin and everyone else was just having, where's the best place to continue that? Is there a magician's thread we can link to in chat and on the Core Dev Getter?
I will find it while you continue.
Okay, that sounds great. So yeah, any feedback is greatly appreciated on that, since that one is one we're wanting to put in Berlin. And do we need to discuss Berlin timing today, James, in your opinion, or it's getting into March? I didn't know what we had originally said we were trying to kind of roughly group together as a date.
I don't think yet. I would rather see some of the testing from the BLS stuff happen. So perhaps next week we should
Okay.
talk about.
Yeah, there'll be some updates on there at that point, I'm guessing, too. Okay, thanks. All right, so main agenda, items after that. We have, and again, we went out of order on the agenda for those following along, so we did item 2 before item 1. So the first one is EIP 2537, which we talked about. EI 1962 fuzzing, that's the EC arithmetic and pairings with runtime definitions from Alex Vlasov. And did we just talk about that too?
No, we didn't. No, we just said that it's been excluded from the Berlin.
Yeah. We talked about 12381 right at the beginning.
Yeah, well, there is a separate discussion about the fuzzing that I wanted to start.
Yeah, go ahead.
Yeah. So essentially, well, although we kind of know that this EIP 1962, which is the generalized elliptic curve precompiles, it won't go into Berlin, but I think it's still worth pursuing it. And so far, what we have to summarize is that we have a very good documentation. We have implementations in 3 different languages. We have some tests, basically the fuzz test, and this is where I started to look at it, and and at the same time, I actually happened to read a very good article about fuzzing written by some guy at Microsoft, which actually does the fuzzing all the time. And so now I started to understand first of all, how cool that is. And secondly, how can we use the more advanced forms of fuzzing to actually progress this change, 1962? Because it also the realization came to me that if we simply rely for the AIPs, if we only rely on the sort of manual inspection and our sort of really primitive cognition, or relatively primitive cognition tools, like our personal cognition to verify them, then it will probably exclude most of the very interesting but non-trivial changes like this one. So because this one is definitely a complex change, and people are basically sort of feel that, okay, it's too complicated to be even reviewed or correctly, or we need more experts to review it. So now I wanted to say that if we employ some automation here, we actually will be able to reduce a cognitive requirement for this. And then I'm hoping that this will allow us to be more confident about such changes in the future. So what we've basically done is, Julio who's also on the call, I asked him to start looking into this. And the approach that we've taken is first look at what the current fuzzing tests are doing. And so what they're actually doing is what I call the black box test, is that they generate random inputs in the form of some sort of random pieces of byte strings, and they try to feed it directly as an input to the precompiles, which unfortunately, as far as I understand,
because the points must be on the curve.
Yeah, so unfortunately, that means that most of those inputs will not be valid points in the curve, and they will basically just trigger the validation code and not go into the arithmetic itself. So Julio can now explain what we've been doing instead.
Okay, so what we're going to do instead is basically, instead of generating a completely random piece of data
as they were as the fuzzing is right now. We are now just creating keep creating random data, but random data that actually have a meaning. So we create a random point that are on a random curve, but that are not completely random. Because what's now happening is that they create a random curve with random points that might be not on the curve. So what we are doing, so what I'm planning to do now is basically creating a random curve and then figure out points on the curve and then do the arithmetics related to it.
Yeah.
Also, yeah. Also, we found also there are like I had some problem with the parsing, so I figure out that maybe hfuzz is not the best for making this kind of fuzzing. Maybe hfuzz is not the best framework to use because they are too random.
Yeah, so
So
because basically if you have to essentially generate the not just so what we're trying to do now is that we're trying to interpret completely random number as an x coordinate and figure out the y coordinate, but also we also try to interpret them as a coefficients of the curve, which sometimes leads to the invalid combinations of the. So you basically have to have a specialized random number, so generator that generate correct curve, then generate correct point on that curve, and then invoke the computation. So is that right?
yeah,
Yeah. Well, I should most likely comment on this. Well, first of all, as instrument as it is, that would be able to. I think I've seen the tool for Rust language at least, which has like simpler way to define such advanced mutation of the inputs. I've seen it's available in Rust, and I think it was released by Microsoft itself, but I never used it. So maybe you already use this, and this would be a valid approach, and it can be used to test BLS 12.381 precompile. Second, I just, for your information, I should note that current fuzzy testing code, it compiles the precompile with a special feature, which disables most of the checks. So when you feed the random strings there, even while it's complete nonsense, and even while after you construct the curve and you try to feed x and y coordinates, and they're actually not on the curve, like a very little chance that you will hit the curve. So this check is explicitly disabled, but still you get complete garbage as output. But this garbage is consistent, like what we wanted to check as it first, it doesn't crash, even in this case. And the second, if all these computations actually pass, they will never pass in a release mode, but in principle, we just test the code workflow. If these computations pass, even on completely random inputs, they still get the same output between different implementations. It was the main kind of
Yeah. So that's basically, I think,
main target.
from what you said now, I think this is a valid approach, but obviously it's not complete. So in some sense, so I think we need three different types of testing. The ones that you described, which is the differential testing between implementation, and then we also need the tests which test the validation, which could be simply what you do, but with your checks enabled. And the number three is what we're trying to do is actually trying to test the algebraic properties of the arithmetic. So essentially, we're taking commutativity, associativity, bilinearity of points. So we want to make sure that we are generating the points in the domain properly so that we can check that arithmetic is actually performing correctly. Yeah.
So if you're doing that more specific one that checks to make sure all the properties are conserved, then doesn't that kind of also include the arithmetic from the completely random point?
Well, at least for now, for PLS 12.81 implementation, which I made as kind of the next layer on top of EIP 1962 code, there are already tests for basic arithmetics. So those are just tests which basically tells you if you add up 2 points, like if you add the point to itself, you should just get the result, which is double the point. So you just invoke different functions. Same way you test for the distributivity and associativity. So this is already kind of partially implemented for BLS, But if there would be a tooling available, which would be which would allow it not to write this manually, but spend much less time defining all these rules, this would be a great addition to fuzzy testing of whenever would be necessary to include after.
But does the current fuzzy testing that you guys use, does it use introspection to see how good the vector is and mutate it based on that?
No, it doesn't. So we currently basically using it in a sense that we do not have a semantics of code and try to do coverage. At the moment, we started off just do a first simple step is trying to using our understanding of what the domain of valid inputs is, try to generate it there. We probably, if this goes on, we probably will start looking into, for example, there are some optimizations for certain type of curves in the code. We also want to have a drill down into those specific curve types to generate more points there to try to test those optimizations. So for now, the answer is no. We are basically doing it manually, but that's, I mean, from my point of view, the importance of this step is to even start. It's like to me, it's like a start of the independent review of all these things, because it's like you start touching the code, you start figuring out what it does, and
yeah, definitely we need that. I mean, and it's what we've been doing for a couple of years, fuzzing the EVMs well on the libfuzzer path, where we do actually try to maximize the code coverage and get the code coverage out from Geth and parity, and maximize both of those. And if you guys can get the same, I think we could actually get good coverage of 1962, which is impossible if we only have random inputs.
Yeah, so what I wanted to get in this call is to general kind of broad agreement that what we're doing is useful and we should continue. And so that was kind of the goal today.
Well, for me, it would be useful to, if you guys form an opinion about 1960, a well-formed independent opinion would, in my mind, be useful.
Well, 1962 might be I think a little bit of an uphill battle at the moment. Doing it on like the BLS precompiles as like proving it seems like a good way, perhaps.
Right. Yes, I don't know about that. Sorry, somebody wanted to say something before me. I didn't want to interrupt.
I think you're good. You can talk.
Okay, so yeah, I think the effort that we've started right now is actually started slightly ahead of or at least my thinking of this, and then Julia started to work on it recently, before this whole sort of shift happened into the BLS. What is it called? 381. And so I think the original idea for the idea I had was to actually use this white box fuzzing to fuzz this generalized library rather than and then drill down to specific curves, because we know that some of the curves that they have or curve groups, I would say, have a specialized implementation, and then we can turn into there. Yeah, we could, when we are confident enough that we are doing a good job at the generalized curves, we could probably drill down into specific ones. But we are actually learning on quite a lot on the way. So
yeah.
Well, you convinced me. But is there other thoughts or opposition on the call?
So what fuzzing tool are we talking about using?
Currently, the black box fuzzing that the ape is currently using is HFuzz, which I believe it's some Microsoft fuzzing tool, right?
No, well, HFuzz is kind of the branch from one of the Google employees. It's not official Google product, but it's from one of their employees. Well, in principle, it's a repository which is public. It has bindings to kind of call all available fuzzy testers, including libfuzz, AFL, and HFuzz, which is HonkFuzz. I found, and I usually use HonkFuzz just because it's the fastest one. and it has a multi-core support from out of the box. For example, AFL has very poor support for multi-core testing, and for some reasons, LeafFuzzer is factor of 4 slower on my machine, even when it's in multi-core mode. So it's up to personal preference, I would say.
Real quick, have y'all looked into? And I am not an expert in this at all, but VFuzz by Guido Vrenken, because he is a friend of Ethereum, so he would be. And I think we're using that right now, aren't we, Martin? Like his stuff.
Yeah, we're using his stuff, but it's libfuzzer
Based. Okay. Anyways, if anyone's interested in talking to him or like looking at what he's been working on, I just posted a link to a Twitter post of his. Any other comments on that? Oh, go ahead.
Yeah, I just wanted to ask again exactly the same thing. So I sort of sense the generally positive attitude to continue this work, right?
Yeah.
I would say yes, and I think it's part of the problem is testing, and especially fuzz testing is not a lot of people's expertise, so it's hard for anyone to come up with the negative or opposition thing to it because they don't know the stakes or any of the technicals behind it necessarily, is my guess.
Okay, cool.
I as point of process, I think we could leave 1962 as EFI and not make it superseded with this work happening.
How can? But it's not EFI. How can it be leave as
Oh, it
EFI?
wasn't? Well, then you're probably right.
I forgot if it was EFI, but we can look at that.
I mean, it doesn't really matter at this point as far as like I just wanted everybody like two things. I wanted everybody to know that we still want to help to implement it because I think it has a usefulness beyond the BLS 381 curve. It has quite a lot of potential for inclusion, for basically for Ethereum to be more inclusive for other applications. And so, secondly, I just wanted to sort of get the sense of whether people think it's a good direction to go.
Okay, so not as an official EFI, just wanting to get a sense of direction. I understand now. But yeah, I'd say go ahead. Is what I'm feeling from the room.
I'm still to be convinced, but sure, go ahead.
Okay. Any other comments on that? All right. EIP 2542 is next. That one is for adding TX gas limit, call gas limit, and TX gas refund opcodes. That's going to be Alex Forstadt. Are you on the call?
Yeah, hello. Can you hear me?
Yes, I can hear you great. Go ahead.
Yeah, okay. So the situation now in EVM is that there is an opcode for gas limit, but what it returns, it's a block gas limit and not a transaction or call gas limit. So out of all the parameters the transaction has, like value, sender, gas price, only gas limit is not available for a smart contract to use. And it creates some limitations. For example, the common use case is like to know how much gas your transaction uses. And the current like best practice approach is to like create in Solidity a variable to hold the gas left in the beginning of a transaction, and then subtract from it. And it's also problematic because it doesn't take into account the call data cost, and it doesn't give you the full picture of the entire transaction. It can only work for the current current call stack. So tell me what you think about it. Is there like a reason not to have?
So what would you do with by gas limit, you mean the actual original gas that was specified with the transaction?
Yeah, right.
What would you do with that information? How can that be useful?
Like, for example, like which context it raised as a problem is we are working on a gas station network. So in context of meta transactions, sometimes you have a bookkeeping of who spent how much gas, and knowing how much gas was used and refunded, and all of the parameters of the transaction is critical. Otherwise, you need to make an approximation, like for
right.
One use case we have.
Why don't you want the operation gas instead?
Because, for example, if you have in Solidity a public function that takes a byte array, variable size byte array, then by the time you have gas left, you don't already know how much gas was spent on a call data and call data load operations. So like that one is lost.
But
And
you'll never
again,
know. You'll never be able to trust the gas limit anyway because they've done other things before they called you, right?
Right. That's why I propose a gas limit of the entire transaction and of the current call frame. So like you can figure out what the situation is. Like I would be happy to appreciate any input on how this can be achieved or why it doesn't need to be achieved.
Well, I have when I read it first, of course, I had the knee-jerk reaction to this in my mind, because you might remember, or some other people might remember, we were discussing the ungas proposal previously, which is basically the way to completely hide this information from the EVM. So because we kind of realized when we were looking into stateless Ethereum and trying to make the gas changes appropriate for the witnesses and the history of AIP 1884, where some gas cost of some operations were increased. So we sort of realized that the introspection tools of the EVM in terms of gas, so the ability for smart contracts to observe the internals of the internals of the EVM looks like a cool feature, but it actually it inevitably leads to the brittle code that will be broken when we try to do anything with the gas schedules. In the same way as there's already opinion that, for example, the chain ID opcode might actually be bad in the same way that if you because it allows the contracts to introspect the chain ID and then they start building the code depending on specific chain ID, and that basically that code becomes unforkable. And so my reaction to this is actually it goes directly opposite the sort of leaking abstraction narrative. Yeah, that's my first reaction into that.
Yeah, I just want to add some comments on the backward compatibility issue. So if it was like 3 months ago, I would be like really strongly opposed the CIP because I said there's some backward compatibility issue. But then I realized there is actually the gas abstraction in Ethereum is actually a leaky abstraction. So it's actually nearly impossible to entirely hide everything related to gas from the EVM. Because after all, what people can do is that we can check, for example, we can check the balance and figure out the phase of a transaction, and then use that to figure out the actual gas used from the transaction, even if we had the ungas proposal. So what my thinking becomes then we need to preserve the backward compatibility like in the best possible way, even if the complete backward compatibility is impossible. So I think the current what I'm currently thinking is that the biggest offender is the gas parameter in all these call opcodes. So I'm thinking if we don't do ungas, we just do a part of the ungas that change those gas parameters, change the error handling inside the EVM, then that might be enough for most of the backward compatibility needs. For example, for the 1884 case, that will be sufficient. And in that sense, then if entirely hiding the gas information from EVM is impossible, then I think in like introducing something about the gas limit, like allow people to access the gas limit as value may not be that bad, but I still have some holding some preservations because it's I still can't say I figured everything out. Yeah, just some comments and yeah, another I just want to add a comment on the actual specification for this new opcodes. There's one called call gas limit. I just think it might be useful if you specify it more clearly, because there's some rules in the when you issue a call opcode, the gas change is actually quite complex, and what I know is different implementation. I don't remember there's actually a concept of gas limit of current execution frame, and I remember it is possible to implement this call gas limit in different ways. So you have different values, but it's still give you the same result. So just think it might be useful if you specify that more clearly. What do you mean by how do you think the EVM should extract this call gas limit information? And also the gas, the TX gas refund. There are also issues in the implementations, because we know the gas user implementation that is kind of a journal, a log based. When you enter a call frame and then it creates a new journal log, and then when some calls fails, the refund, that journal is reverted. But in the Open Ethereum is implemented differently. We have something called substate. So in this case, the gas refund value, the TS gas refund value might have different meanings in different clients, and if you specify it in one way, then it will be difficult for the other type of implementation to do that. So that's something I think need to be fixed. I don't know what's the best way to fix this, but I just think this is something need to be fixed.
I've been noticing kind of two general directions happening as far as development goes. The ETH1X group is working on removing some abstraction leakage and moving towards something like ungas as a way to, because it really helps stateless Ethereum, which is currently actively being developed. And I'm also seeing the meta transaction community coming forward with proposals on how to make it easier. I would love to see the meta transaction community looking at the ungas proposal and then see what they could do, or what could be done to allow for what the thing that they're trying to get out of this, which is allowing other people to pay for other people's gas or such. I guess I don't want to say what it is you guys are looking at, but looking at from what you're trying to get to in the frame of reference of ungas, I'd really like to see.
I have one question. So I haven't read the thread on the Ethereum Magicians, only skimmed through the EIP. And so one thing that's super unclear to me is what the actual real world use case of these features would be. Because the EIP only mentions these theoretical things that, well, if we have access to these fields, then the contract can emit some events. Well, yeah, but it would be nice to know why does the contract need to emit these events? So it would really, really help understand the motivation and maybe suggest alternative designs if we knew exactly what the end goal here is.
Okay, so one use case that I think we demonstrated a few demos is like using a permit function of a DAI contract. I think we allow people to pay for gas in DAI without holding Ethereum, like not directly, but using a relay server. So like the entry, the address that actually pays for gas in Ethereum receives a compensation. So it is, in this case, it's important to know during a transaction how much gas the transaction costs. So like there are two parts of the transactions. One is the transaction that the user actually wanted to execute, and the other is wrapped by a relay contract. You can see the implementation on gas station network, GSN. In this case, we currently make an approximation of how much the transaction actually cost. But ideally, that would be like zero sum, so like everybody gets exactly the same amount of money, and nobody like without approximation. That's one use case that's common, and I think there are more. I did not come up with a list of possible use cases. But arguably, knowing how much the gas your transaction used is, and what the actual gas limit of this transaction was, can be helpful.
Well, my other piece of feedback is essentially like these are the mechanisms, because I saw the similar mechanisms is let's say in Gnosis wallet, where they want to be able to, let's say, have the owners of the wallet without having any ether and just submitting transactions, but not to the chain, but to somebody else. Then they can just post it and then executing it on their behalf, and then basically be able to pay some fee for it. I sort of get this, but I also think that maybe even without this opcode, maybe we want too much automation in the smart contracts. Maybe in this use cases, it's actually useful to have this automation taken out of the smart contract and applied like on the server before you actually execute transaction. I know it basically shaves off some of the cases, but maybe the way to trying to put all of the automation inside the smart contract is not the best idea if you try to sort of to touch all the internals of the EVM. Because the reason why yeah, go on, Martin. Yeah.
I didn't mean to interrupt you. I was going to say, though, that I think if we were to add all this, I think it would still be very, very brittle solutions. So if I wanted to make a meta transaction, make a transaction on behalf of someone else, I could first make something which set some storage slots in that Phil Diane's thing where I get paid later for my storage slots, and then I do this meta transaction, and you would look at my origin gas and say, hey, you paid a lot for the call data there. And these kinds of tricks that would still make it gameable, the whole thing. And yeah, I don't think adding this would solve the problems that you guys are facing. I think it would just lead to a new forest of problems.
I'm not sure I understand the problem you described. I would be happy to discuss it in detail. But
I think I think from my point of view, my general opposition to this is not because I think it's useless, but I think it's actually quite a high cost to these. So these instructions, they specifically two last ones, like not the first one, but the last one. That's the other two, which is basically a refund and the gas call limit. These are the two pieces of information which are described in yellow paper, but at the moment they're not really accessible from the EVM, and that means that you can always, so if we want to modify the EVM, we can do that because we know they're inaccessible. However, if we add those things, it means that we will never be able to, not never, but it will be hard for us to, let's say, do something about refunds, like maybe change the logic. And it's sort of, to me, it's putting shackles on our future ability to fix things. I don't know. That's I think the cost probably could be quite high.
I agree.
I think that at least one of those suggestions, a transaction gas limit, is totally okay to implement, because while we may be a bit cautious about things like refund counter and call gas limit, which are internal to the execution of EVM, the transaction gas limit is more as a environment input, the same way as gas price is in, and we never had really any trouble with the fact that gas price was there.
So,
but in this
yeah.
case, so you can actually, if you care about this one, then you can actually pass it inside the transaction as input if you are the one who controls the transaction creation.
And I think actually the TX gas limit, that is the same kind of opcode as origin. And origin is one of these opcodes that probably should never have been implemented because it has 99% of the use cases for it are bad. And if someone relies on it, it's probably for the wrong reason. And I think the same way, this like the origin gas, that can be gamed in most circumstances where it's used. And so I don't like it for that reason.
I think it could be substituted. Like if you're the person who is generating transactions, you are actually controlling that number. So you can pass it in as an input argument, I would say. You don't need opcode for that.
Well, I guess the use case here was that essentially if I want to DAI or Maker or whatever to pay on my behalf for the transaction, then I would like to tell them that, hey, please run this transaction, but I also want to enforce that they cannot use more than some amount of gas. And I think this is where the whole thing revolves, in that you can make, even now you can grant a contract permission to take away your DAI. And then the problem is that you cannot say that, okay, this transaction must not cost me more than $1 or $0.50. And I'm not sure that you can solve that without actually having access to the gas things.
Yeah, it's a different case when the smart contract is being controlled by the person who's passing this as a parameter. But if as a smart contract you want to make some refunds or guarding based on the actual transaction gas limit, then you cannot allow this to be an input from the transaction creator, because the transaction creator then can insert any higher number of gas.
Well, I guess that basically the discussion goes into like, okay, if I'm not trusting anybody who is calling me, is it really like, I mean, because if you know which contract it's called you can sort of say, okay, if that contract which could call me, I can call it back and figure out what that number is, and something like this. I don't know. I think it needs to be thought through. So this
it's about transaction gas
yeah.
limit, so it's not a contract calling, it's external transaction calling, and obviously we cannot have any trust there.
No, yes. I mean, if you're calling into your own contract, then you can have a trust because you're actually the one who creates the transaction. But
yeah,
I think
we're not talking about calling your own contracts here.
Right. Oh, I mean, you called the other contract directly. Okay.
Yeah, Alex, what is this? Are there is there any further specific explanation you want to provide for what we've been talking about?
About the use case we are having, or about the
Yeah, do we need all three of these for the use case, all three of these opcodes, or can we get away with just the one we're talking about
do
mainly?
think that transaction gas limit, I do think it's like most important, and I see that it's easier to implement because I understand now that gas refund and call limit are not as easily available. But about the use case, I'm talking, then of course, like there is a singleton contract on a network, and any externally owned account can make a transaction to it with a meta transaction like as a parameter, and be sure that the address will get back the money for making this transaction from that contract, or from like, I don't want to go to the details of the solution, but the core concept is that there is no trust between like somebody who makes a call and the contract. So it's not like a contract can take a parameter like gas limit and be sure that that is what happened, because it will like pay this money back to whoever made the transaction. So the contract obviously wants to calculate and know the gas limit that was given in advance. So
but Alex, at the same time, the gas limit practically, you can calculate the gas usage or the gas limit based on the gas opcode plus the call data size,
Yeah, that's what we,
give you the exact number.
Like it's not that simple for like you can, but one that would depend on an opcode price of not opcode, on call data price per byte that was recently changed. And second, like you would to get a precise number, of course you would need to go and see which bytes are zeros and which ones are not. So or you can again approximate. So, and again, if it's a public method in Solidity, what Solidity does is it loads it into memory for you. So then you would need to also take that into account. And I think for our use case, it's not a requirement for it to be public, but Solidity does have a poor implementation of call data structures. So like it should not motivate any changes to EVM, of course, but that was a problem.
Can we get a just a couple final comments on this from anybody, and then just move it to the Ethereum Magicians forum? And Alex, if you can take some of the feedback here and change some of the EIP, I think it's missing security considerations specifically, unless I'm missing it here. And you can reach out to me personally to merge this if it's not auto merging after the EIP is well formed.
Yeah, okay, I would be happy for someone, if somebody is interested, to help me out on this, because I'm not actually a core developer, so I'm not familiar with implementations of clients. What is
Great. All right,
yeah.
so yeah, and how can people get in touch? What's the best way? Your email?
Yeah, I'll just
okay.
I had one question.
Sure.
Alex, you said you were with the gas station network.
Yeah.
Is a gas station network possible in the ungas world?
I am not sure. I'm not that familiar with ungas world, but I think like from what I heard on this conversation, it seems like the idea is to abstract the gas out from the EVM, right?
Pretty much.
So I'm not sure about that. I need to look at the proposal. It seems like not, because like what we do is basically a on-chain gas bookkeeping.
Okay. Thanks so much, Alex. And we'll move on to the next thing now. Instead of going to item 4, we're going to go to item 5 only because it is actually in EFI currently and the others are pre-EIP proposals. So we're going to go to 2046, which is reduced gas costs for static calls made to precompiles. Alex Bergzazi, I think you're on here. Axic? You're on mute if you're talking. There you go. Oh, I thought you got off mute.
I placed the comment about this into the agenda.
Oh, I was just looking at the author. Sorry. Go ahead.
Yeah, there was no like no one was pushing for it, even while it was there for a long time, and there were 2 other proposals before it to do this price. And Martin also posted his evaluations at a number which is in the proposal is reasonable for reduction. So I just wanted to propose that it should be eligible for inclusion, and the thing we should resolve is just check that current gas price for Blake precompile does not include this like virtual 700 gas stipend into its pricing. And I think it should. I think it doesn't, and I think like the way how the benchmarking is made, it never takes this 700 gas into the account. So the benchmarking for precompile right now just calls the raw precompile code with some data, without any stack context changes. So it just tells you the number of actual execution time. And then there is in principle no obvious problem why not to include this. Maybe it's up to discussion to what range of addresses it should be used, but this change would help a lot, especially if you do a lot of hashing. Like if you want to check the Merkle tree, for example, you do a lot of individual invocations of kcheck function or any other hash function. It would help a lot. Same way for applications with elliptic curve arithmetics. If you do a lot of point additions or multiplications, you pay a huge price penalty just because you pay 700 for invocation of the function which calls itself, more like much less, like roughly half of it. So I would want to see this included, especially if there were already measurements done on this, and even while AXIC is not that active on it anymore.
I want to like to also agree with Alex on this one. Blake, for instance, should be faster and cheaper than Kechack. In practice, it's not, obviously, because it's a precompile. At 700 gas, it's just not even like we can even think about it to use it for anything, except like pegging Zcash and verifying the proof of work for that.
So, Alex, are you saying that the benchmarking being done for instance, the BLS curves are potentially mispriced because of the fact that we are pricing static call at 700 currently for all precompiles?
No, I mean, what I want to say is that the way I've seen benchmarks implemented, and in any sane benchmark would implement it in a way that the execution time and the gas schedule for precompile would be the pure execution time of the precompile. So you just take the raw data and feed it into the input. You don't touch this 700 part, which is only due to EVM conventions. And as far as I believe, all the precompiles right now are priced in this way. And I can guarantee that BN precompiles are priced this way, and BLS precompile also priced this way because I did the pricing. So usually the cost of the precompile should not, and at least as far as I understand for most of them, it does not include 700 in any form. So it's just the benchmarking and the gas price of the current precompiles. It's just what is an execution time for a given input. Like what is the cost of the execution time? So you virtually, when you call them, you pay 700 gas for nothing.
Okay. Martin, you had a comment?
Yes. In theory, I agree. 700 is too much. And my measurement on Geth shows that, yeah, sure, we could go way below that. And I totally do not agree when you say that it has not been factored into the cost of any of the precompiles, because it definitely has. And we have priced precompiles thinking that, yeah, well, we still have the 700, so this should be good enough. And if we remove that and set it to 40 or whatever, then yes, we need to redo all the work and benchmarking all the precompiles to make sure that when we lose this margin, we do not get dosable. And I'm not opposed to that, but someone needs to put in that week of work or whatever, how many days it is, to gather the data and do the analysis and put the actual numbers up.
Can you name specific precompiles for which you did something like this? Because
yeah,
I checked the work of Zach on 11 or 8, and like my work in BLS, I can be sure about this. If you tell me other ones, maybe it's just easier to check them. And
well, I mean, we have like 12 precompiles. We need to check all of them.
Well, I mean, there was a recent reduction of the price for BN curve, and the benchmarks from there, just the way hours they were done, and I just used the same kind of benchmark to measure EIP 1962 and BLS 12381, and those did not include 700 gas depend. So the prices there are just pure execution time.
Right. But there are more. I mean, there are more precompiles, right?
Yeah. And if you say that potentially all other are measured in some mixed way, then it may be just easier to remeasure them.
Right, and that's what I'm saying. I mean, I'm not like saying I'm totally against it. I'm just saying we need to measure everything, and make sure that we measure it kind of in the same way and same across all. We can't just assume that removing 700 doesn't affect anything and it's all good. We need to actually show the numbers. That's just what I'm saying.
Yeah, can we just formally, can there be placed a note somewhere that for any other precompiles or changes, precompile costs should not invoke the 700 gas stipend? So people would not do something like this later, and it would be much like, and so the kind of meaning of the precompile pricing would be homogeneous.
Can I suggest quite a question for to Martin for I guess Alex for understanding what would be a good benchmark? What are the expected runtime of the entire block for the VM today? What is the upper limit we define as acceptable?
I think I would say that somewhere around 200 milliseconds is kind of a norm. It's kind of expected.
So running the precompile and call it like until we fill the block and see what is the price of calling it would be like a way to see how things go. I mean, let's say we put the calling of the precompile to 40 gas, and then just computing the entire block, filling the block with this sort of this operation would be a good benchmark, or is it something that what would you do to push to test it?
I can give a simple, like the recipe how I did the benchmarking, and you basically take your favorite Ethereum implementation and you try on your own machine to run the benchmarks for easy recover and all BN precompiles, like additional multiplication and pairing. And then you will get some set of numbers which will tell how much gas you pay per second of execution time on your machine. On my machine, it depends on a precompile called, and it ranges from like 22 to 40. So I use a number of 35 as a conservative estimate. And then I priced the EIP 1962 in this form. So you can do this like the simplest way, and you can even most likely grab the code.
Yeah, I think what you're describing, it sounds like it's based off the Ethereum /benchmarking repository, right?
Yeah, I mean the logic is the same. It's just I taken the parity code and run the same in the rest.
Just for some context for you guys, where this came up in Berlin, Istanbul, in the conversations, this EIP, and generally everyone was like, yes, we're supportive of it. It makes sense. 700 is too much. We need to go it lower. There was certain things that were hairy like this that needed to actually be verified before we figured out what the real number should be. And just saying, oh, let's shave off 100 was not really the finding out what actually is safe and all of that stuff. So if Alex or Luis from your end are able to put in that work, I could see this going through pretty easily.
Yeah, I agree.
I will need to check internally if we have some bandwidth to do it. In my side, I ask Alex to see if he can find some bandwidth.
Yeah, and what I'm thinking is for things like this, like boring stuff like benchmarking that takes up, time. I think Martin said like a week time or less. We might be able to do bounties in the future because it's not like, I mean, you have to know some low level code, but there are people who don't attend these calls that could definitely do it if there was a sufficient enough bounty. So maybe, and I know we've done that before for testing and fuzzing, and that's worked out. So I think that's something we could try if we can find someone willing to put up that money, or the EF, or Open Ethereum, or any of the other groups or people who are interested in this going in.
Would you think of doing like a Twitter call or someone like Twitter message saying anyone this CIP can be useful if we need someone to do the work, and someone would like maybe people could come in and pitch in some cash to push these benchmarks.
Yeah, doing that'd be a good first step, and then using a platform like Gitcoin to organize it would be giving it more publicity and more outreach to the devs already on there. So yeah, that's a good idea. And if you want to talk to me offline about that, I can say kind of my opinions on best way to reach out to a wider audience about doing something like this. but I do think it's valuable.
I'd say we should move it into. I'd motion to move into EFI.
It's already in EFI.
It is.
I believe so. If this is 2046.
Cool.
Yeah, and then also just as a point of process, as we were talking about earlier, 1962 is an EFI, and we looked through the notes, and it looks like there. So Pooja said in meeting 78 it was entered into EFI. I didn't find anything explicit. I saw some stuff that might have been implying that it was. I really think that what Tim said about it being tentatively accepted in meeting 66, which was in the summer of last year, it was tentatively accepted before EFI was a thing, and so it got grandfathered into EFI because it was tentatively accepted. And I can't find where that particular, I guess, pivoting point happened, but that's what I think happened. James or
That's
others, do y'all remember it that way or remember
that
something
sounds
different?
that sounds right. I remember it. That sounds how it happened. There was a day where we did a whole where we basically said things that were tentatively accepted were moved into EFI.
Cool. Are there any other comments on that? Okay, we have a little less than 10 minutes and we have 5 pre-EIPs to go through. What we can do if we either don't get through all of them or we don't get enough discussion on each one, which we won't, is to bring them up first next time, since we spent a lot of time updating on some of the EFI and Berlin EIPs, and we can dedicate some time to these pre-EIP proposals. So let's spend about 2 minutes on each one. So the draft of transaction post data, a new field in transactions that cannot be read by the EVM, is EIP 2242. And I believe that is John Adler, if you want to go ahead and just give an overview and where people can learn more, and then we'll do that for each EIP.
Hello, can you hear me?
Yes, we can.
Great. I was thinking of more giving, since they're all related, I was thinking of more giving kind of motivation for all of them together.
Oh, are you all these EIPs?
Yes.
Oh, then yeah, do that. You have like 9 minutes, because I think other than that, there's nothing else pressing. Is there, James?
Nope.
Okay, yeah, go ahead.
Great. So I'm here on the call to kind of get some initial kind of high level opinions on whether these pre-EIPs are even worth pursuing. If there's strong opposition, then obviously that means that there's no point for us to bother speccing them out and implementing them and testing them and so on. But in the absence of strong opposition, then that's what we're going to be doing. So the high-level motivation for this is to generally make rollups, both optimistic and ZK variety, have access to more data availability and all their nice features. So it starts off with the idea that for all the rollup constructions, generally what you want is you have a bunch of transaction data in the rollup that's posted on chain as call data, and then you want to have an authenticated commitment to this data, and this needs to be done on chain. So you're either going to be doing a simple hash or you're going to be Merkleizing it. And then additionally, for optimistic rollups or fraud proofs, you also want to do things like Merkle branch verification. So we note that computing authenticated commitment and doing things like verifying a Merkle branch, these things are pure functions. They don't write to the state, and more importantly, they don't read from the state. Since they're pure, this means that they can be multi-threaded. So you can imagine a situation where, let's say, a huge amount of transaction volume is moved to a rollup. Then you can, if you target 4 core computers, you can have 4 commitments to these transactions in a rollup, and then authenticate a commitment to these data blobs. Like you can authenticate 4 of them in the span of 1 block that you could do now, if you did them in parallel. For example, that's kind of the high-level motivation. So obviously, there's going to be a number of details and whatnot that we can complain about at a later time. But this is, for now, this is kind of, are there any strong objections to the following proposals? So the first one is a new field in transactions. This can't be touched by the EVM. And then specifically this, I call this post data just for lack of a better name. The second EIP is allowing execution over post data using any precompiles or any pure precompiles. And this will allow multi-threaded data availability processing and things like Merkle branch verification, which could be useful in other contexts. For instance, if you have a stateless contract. The third one is adding new precompiles for Merkleization and Merkle branch verification, which is really only useful with combined with the above. The fourth one is reducing the gas cost of call data to about 2 gas per byte, and similarly setting the gas cost of post data to somewhere around that. And lastly, a new opcode for the current transaction hash, which is potentially useful for optimistic rollups and might be useful just in general, and is kind of orthogonal to the other 4 in terms of what it provides. So that's basically it. Does anyone have any questions or any strong opposition that these things will never be viable and should never be even experimented with?
My questions are, so I'm actually curious. So essentially, if I understand this correctly, the net total effect that this would have on the chain is that we would have certain transactions that are kind of huge. Now, if we say that it's 2 gas per byte, then we could end up with a transaction currently that's 5 megabyte in size, and that would be valid, which also means that we could end up with a 5 megabyte block, which would be valid.
That is correct, yes. This would also, reducing the gas cost of call data would also, I guess it wouldn't have to, but it would probably be simultaneously included. There would also be a simultaneous increase in the max block size, just in terms of bytes. But it is not necessary to also increase the max block size to say 5 megabytes.
Yeah, well, yeah, I guess my question is that this does have a few practical limitations. So I mean, the implications from the EVM is a different discussion than what I'm talking about now. But from a data storage and data distribution perspective, essentially 5 megabyte blocks would be a significant hit, so to say. I mean, they could cause some significant issues in the network. First up, the Ethereum, the networking protocols will not be able to propagate that. So I'm not sure that. So honestly, if you were to produce 5 megabyte blocks one after the other, I'm almost certain the network would choke on it if it gets a 5 megabyte block every 15 seconds. So that's definitely something that needs to be, that would also need to be solved.
That's
somehow.
correct, yes.
And the other issue is that if you allow 5 megabyte blocks, then running a quick calculation, essentially that would permit the Ethereum chain itself to grow by 28 gigabytes per day. That's a big number. So currently the chain, the stable, essentially all the receipts, all the headers, blocks, everything is 127 gigabytes for the past 4 years. And your proposal would allow to create 25% of that per day. So essentially 1 year's worth of growth creatable per day.
That's correct.
Yeah.
So there's a few rebuttals, not to the point, but to the implication that this is an issue, or the explication. If you look at the cost of a hard drive, it's very cheap. It's maybe like $50 for a 1 terabyte hard drive. So it comes out to maybe a couple dollars a day worth of storage costs or less. And this is assuming you buy a performant hard drive. If you buy one that's just for archiving data, because you can store this on a hard drive, not an SSD, then you're potentially looking at under $1 a day in terms of storage costs. So this is not inherently significant, but this is also only for full nodes that must.
Yeah, but wait, that means that the storage costs. So if I have 8,000 nodes in the network, then you just dump $8,000 worth of cost per day, cumulative cost. So so let's suppose that currently Ethereum doesn't have chain pruning or anything similar, which means that these $1 keep adding up. So after 100 days, it's actually $100.
Yes, but chain pruning can be implemented fairly
for
trivially.
everybody.
And not all full nodes need to store all historical data.
That one, I completely agree with that. Chain pruning can be implemented fairly trivially, sure. If you throw away the Ethereum chain, it can be implemented fairly trivially, and it also becomes impossible to recreate a full node archetype node. So you lose the data availability there in the network. If you want to retain that, then all of a sudden it's not so trivial to implement chain pruning.
I think there's a few things that have been brought up in the last 5 minutes, and basically, some of it is storage costs, some of it is how to improve the network layer to support this. Oh, Peter, I think you're like I'm getting echo from your mic. Oh, there we go. Okay, so if you could, John, and whoever you're working with on this, the group, I would love to see like a blog post that just explains, like in a paragraph, what a rollup is, in case someone doesn't know, and then for each one of these EIPs, like you could put in the EIP itself this stuff like the motivation and the security considerations and the technical specification, but if you can boil that down to something that's like bloggable, I think that would help us look at it from a holistic perspective and then be able to respond on like an Ethereum magicians thread with this part of it, has implications on the network layer, this part of it has implications on the storage layer, this part of it, etc. That's how I would suggest going forward with it if I were doing this instead of you. So what are
And
your
my
thoughts on that?
my suggestion, can I say
Oh
something?
yeah,
So my
sure.
suggestion, to go ahead with this, to be more kind of to be not more, but to be constructive, is that, as Peter rightly said, that yes, this kind of expands these suggestions. They do expand the demand on the Ethereum network, and we don't know like whether what's going to happen if it happens. So I think I would say that the prerequisites for doing that would also be potentially improving our status quo on this infrastructure, like block, not just the block storage, because it's actually oversimplifying, just saying that we have one buck for megabyte or whatever. It is oversimplification of the problem, because this whole thing has to be shuffled around network as well when we add nodes. So we at the moment there's nobody actually actively working on the chain pruning, and so I would love somebody to do that as a prerequisite to putting more pressure on these elements. So I understand that these things are quite promising, the roll-ups and stuff like this, but I would like to see kind of a more investment in the infrastructure as well, because otherwise we have a very sort of top heavy system where there's a lot of applications that trying to build on top of it, and then try to okay, we need this and we need that, but we also need to think about the infrastructure which is currently like, yeah, it's a very thin and narrow. So that's my sort of feeling, that needs to be done together with the looking into the infrastructure.
I just want to react on top of what Alexei is saying. Right now, and actually I had the same issue when we work on 2028. It is very hard, or there is no status quo on what is the technical requirement we want to keep over time, or the technical cost of running a node over time. And all of the improvement we're making here, and the one that John is talking about, as direct, all the parameters basically depend directly on those sort of premise of the cost of running an infrastructure. So I would be very happy if we could also, to help the CIP, which I find super interesting, sort of define what we want to be the cost to run a node into the network. Also, and I guess I can take this offline with John, I discussed a long time ago with you on the Ethereum Magician, and I still do not understand how the CIP does help an optimistic rollup, and I would be very excited to. And a second question related to the precompile using multi-threaded, also sort of, I think, fall back into the premise of what kind of machine are we expecting nodes to run. So I would very happy to take this offline with you and have a direct chat to see where we want to bring this and how we can how do they work.
Yeah. Go ahead,
Yeah,
Peter, and then, or Alex, go ahead, and then we're a little
yeah, I
over
just
time.
wanted to ask much more technical question. Like, why do you want a separation between the call data and some abstract other data to which you cannot have access other than calling the pure functions on it? Like, wouldn't it be much better solution and actually usable for everyone to be able to not just copy all the call data into the memory, but maybe map it to some chunk of the memory and don't pay for this allocation, so you can actually read it because it's already in the memory. So you already received it over the network and loaded it into the EVM. So maybe it would be like a pure solution usable for more than one application.
Potentially,
Just to be able to address the call data in pieces and run whatever you want on this, and just read it directly or use it directly without paying like a double cost of copying this call data in the memory.
Yes, that is potentially a good suggestion. So one of the motivations for having this in a field that you promise will never be touched by the EVM is that you can essentially do a bunch of computation on it and then just evict it entirely from memory. Right, like you can do things like pre-process transactions that have post data in future blocks that aren't the current ones you're validating, or things in the mempool and stuff. You can do all this pre-processing and then just discard the post data essentially from RAM. You no longer have to keep it there.
But more or less a mempool does a huge part of this anyway. Like if you don't process and you never intend to process the transaction, you can even discard it altogether and just keep in the memory pool until you decide that you want to include it. I don't know how it affects the mempool. So in principle, it can be an attack on the mempool. You just shoot something which is huge data, which will never be included, but the mempool will have to execute this to prepare the transaction.
That shouldn't be any different than the current status quo.
I had one more suggestion for the John Adler side, that to look into the stateless Ethereum effort, because there is some, as far as what hardware and things could run and expectations, there is discussion about that as stateless Ethereum progresses. So that would be, I'd recommend looking into that as part of your work.
That's correct. One point I was going to bring up earlier, but then I guess people started giving suggestions, which are all very helpful. Thank you. Is that one of the things that are being proposed for stateless Ethereum right now is blocks that are in the order of 1 to 2 megabytes. So doing something like what I'm proposing here is essentially, from a networking perspective and nothing else, is kind of a dependency for stateless Ethereum to ever be viable. So in that sense,
it's not quite the same actually. So, but yeah, we're not going to go in detail right now. So I don't think you can compare them one to one, but.
And also, I want to react on the current size of blocks today, and I guess Geoff can also comment. When we did the post analysis for 2028, we sort of crashed Solve Machine because of some of the size of the block, and today you basically do not have that big blocks due to client limitation, and client limitation is in so practical limitation of the network. So it's all in the assumption that this is already possible today is actually not true.
Okay, so Peter, you had something to say, and then we'll wrap it up. Unless John had something really final.
Yeah, just wanted to quickly add, just so that people don't go off on some wrong path. If anybody wants to look into chain pruning, that's super nice. I would be really happy for it. Just take care of one issue. A lot of contracts depend on logs and filtering past events. So if you start pruning the chain and you drop past events, then some contracts might go dead. I mean, not contracts, sorry, some dApps. For example, I know Augur, Akasha. These are the two I always bring up. Essentially, this was the part where I stopped my chain pruning efforts. The next step would be actually to just go out into community and see what you would break if you would start to delete past blocks and past logs. it would be really awesome to be able to do it, but it would break some things, and it's important to know what things break. So I just wanted to mention it so that it's not forgotten.
Great, John. Any last words? Man, that sounded like menacing. Anyways, any last comments?
No, I mean, these were all good suggestions. I'll keep them in mind and then follow up with the relevant people at a later time offline.
All right, great. Thank you so much. And yeah, look at the chat for some people who are talking about that, because I know that Tim said Besu was working on pruning a little bit and stuff. And just, we discussed this in chat. We found that there were a few calls where where we talked about 1962 going into EFI. And so I would motion not to leave it. So, James, do you want to kind of summarize that real quick before we go, just to know what we're doing with 1962? And even if we can put it on for next agenda, but like where we are on it.
Yeah, there was a call in November where things that were tentatively accepted for Istanbul were moved into EFI, and 1962 was part of that group. And then we had the longer discussion into it, but it had like an asterisk of things need to be more figured out. And then we've since had the discussion about the BLS precompile and doing that as the strategy initially first. Last call we talked about superseding 1962 for the BLS precompile and having the strategy be create precompiles moving forward for individual curves. With today's discussion on Alexi working on tooling for a path to making 1962 like secure and viable from the group perspective, I'd say we should leave it as EFI as that work is progressing.
I would agree. Does anyone else have opinions on that? Okay, bring it up in Getter if you do. We can always reapproach this next call if there are any strong objections to that. But since it's been in EFI, I don't think that will be a problem. All right, we are 11 minutes over time. Thanks y'all for sticking around, and we'll have notes out in about a week, and we will meet again in 2 weeks. I think. What's happening then? Is that April 3rd? All right, we'll meet again in 2 weeks unless the world has ended. Bye.
Thanks, Edson.
Bye.
Bye. Bye.
Bye-bye.